Good day. My name is FAIAZ NIZAM. I'm a second year mechanical engineering student in the aeronautics track, and today I'm going to be talking about my SEMM 1513 minor project. The objective of this minor project was to conduct design research on a particular mechanical mechanism, and I opted to focus on a mechanical trigger mechanism for my project. And the device that I went with is a spring-loaded toy gun. Now, while conducting research for my project, I came across a plethora of different trigger mechanisms. There are many different kinds of trigger mechanisms, including spring-loaded trigger mechanisms, single-action trigger mechanisms, seared trigger mechanisms, and set trigger mechanisms. And after careful consideration, I realized that spring-loaded trigger mechanisms best described what I was working with here. Next, I looked at some of the purposes which are served by trigger mechanisms, and I learned about how they're used in everything from controlling the flow of water in a bidet to toys, in my case, to firearms, to any other kind of initiating or launching kind of a mechanism, for example, animal traps. Next, let's look at some of the properties which my device would have to inhibit. And this includes, first and foremost, safety and durability, given that this is a toy catering to children. Ergonomics, because it is a trigger mechanism and it has a handle which might be held by a child, so you want it to be comfortable. Next, of course, the sensitivity of the trigger itself and the consistency of the trigger. In terms of components, I list down a few which I thought best described what I was working with here, which includes a trigger, of course, springs because it is a spring-loaded trigger mechanism, a frame to hold everything together, some kind of locking mechanism, a release, and of course, pins and fasteners and other forms of linkages. Now here's a brief description of my device. This is the device that I decided to go with. It is a plastic spring-loaded toy gun. It is spring-loaded because when you pull the loader, a spring expands and the loader locks into place. Once it does, you can load the foam with the silicon tip dart, the foam dart, onto the device and just pull the trigger. Next, of course, we look at some of the different components within the device itself. Firstly, we have the frame. Now, the key property of the frame would be these anchor points, which makes the design of the frame completely toolless. So there are no screws or any kind of nuts involved, which makes it a bit safer as well for children because swallowing hazard. Next, of course, we have the nozzle lock. Now, the purpose of the nozzle lock is very simple. The nozzle lock essentially makes sure that the force of the loader when the trigger is pulled doesn't cause the frame to lose its structural rigidity, given that there are no tools in place. So the nozzle lock essentially goes right in the front like that, holding everything together. Next, we have the loader itself. Now, the loader has two key properties or two key components within it. Firstly, there's the loader lock, and of course, there's the spring anchor point. Now, given that it is spring loaded, you need an anchor point to mount the spring itself. So this is the spring anchor point within the loader. And of course, the loader lock coincides with the trigger lock. We're coming to the trigger in a second, but this is the trigger lock. And when you pull the loader, I'm sure you heard that, that is the loader lock interacting with the trigger lock, locking the loader in place as the spring is expanded. Speaking of springs, the device itself has two springs. Firstly, a larger nozzle spring, which is essentially what holds the potential energy, which is basically converted to kinetic energy when the trigger is pulled. And of course, the trigger spring, which gives the trigger its ability to return to its original position. Now, as I said before, the trigger has a loader lock, and of course, it also has a spring mounting point, because just like the loader, since we're using springs here, and since you want the trigger to go back into place, you need an anchor point for the spring. Lastly, of course, we have our darts. Now, the darts, as I mentioned earlier, is made of foam and a silicon tip. This makes them very safe for children, and we want to uh, reduce the risk of injury as much as possible. And this ensures that, as even if you fire it from point blank range, the risk of injury is very, very minimal. Now let's look at the cross section of how the device is put together, giving us a better idea of how it operates. So as we pull the loader, this is essentially what we're looking at here. The spring connecting the loader to the frame itself expands. Now the spring has two contact points, one with the mounting point in the loader itself, and the other within the spring anchor point. So the spring expands, and as it expands, it locks in to the trigger. The trigger has a locking mechanism, a very rudimentary locking mechanism, which helps keep the loader in place. Next, as you pull the loader and it moves back, it creates space for the dart, which you can load from the front, as we demonstrated before. Next, we have, of course, the spring for the trigger itself, which is mounted to 2 points. Again, one point within the frame itself, one of the anchor points within the frame, and the other point goes into the anchor point within the trigger. Now, as you pull the trigger, this loader lock essentially moves down, and all the energy stored within the spring is released, causing the loader to move forward, transferring, converting the potential energy to kinetic energy within the loader, which is transferred to the dart. Now let's talk about some of the main characteristics of my product. Firstly, the device has a very ergonomic handle, which makes it a very easy to grip, and it is catering to children, so you want to make sure that it's pleasing to them and it doesn't cause injury to them. There are no sharp edges. All the edges are rounded, making it very good hand feel per se. Next, of course, it has a completely toolless assembly, thanks to the anchor points, which makes performing repairs to the device itself fairly simple. You can expect the end user to be able to perform rudimentary repairs to the device itself. Next, of course, we have the trigger mechanism, which uses a very simple combination of springs, which greatly reduces the point of failures within the system itself, unlike most other trigger mechanisms, which can get quite complex. Next, of course, the use of foam darts, as we mentioned before, makes the device very safe for children. Now, here are a few suggestions for improving the device. Firstly, given that the device is completely toolless, one of the suggestions could be that we increase the number of anchor points, thus making the device more structurally sound. And given that, if you increase the number of anchor points, perhaps the points of failures are greatly reduced. Next, the material used for the spring. Now, I have had the device for a very short time, but within that short time, I've already noticed the springs rusting. So perhaps using something like stainless steel or aluminum might make the device a bit more longer lasting, or might make the springs of the device a bit more longer lasting. Next, of course, we talked about the anchor points of the springs. Now, the springs have and both springs have a common anchor, like have anchor points within the frame itself. Now, these anchor points are also used by the frame, like both sides of the frame, to hold it together, and they're also used by the spring. So there's a lot of stress on these two points in particular. So making them very big points of failure, perhaps. Perhaps changing the anchor points or having separate anchor points for the frame and the spring will make the device perform better in the long run, or will make the device last longer in the long run. Next, of course, we have this particular anchor point. Now, the position of this anchor point really restricts the motion of the trigger. So, relocating this anchor point will greatly improve the functionality and the feel of the trigger itself, given that you'll be able to pull it back for much further. And lastly, yes, the anchor points for the springs within the trigger, and especially the trigger, can be made a bit more robust because it is very thin. And yeah, that is basically all in terms of suggestions of improvement. And with that, I end my presentation. I hope this was a good explanation of the product itself and the mechanisms in place. And yes, I hope you all have a very good Hari Raya. Thank you.